Good evening. Mic testing. Please confirm if I'm audible.
Yeah, I can hear you.
Okay, good evening. Yeah, I was hearing Samir. I was calling Jones, the Kisaka, and he's coming in 10 minutes. He's still in another meeting. And we are going to wait for June. Now let me call Safa and Ruth. Okay, I think I called some people, and Kisaka is coming and Safa is joining. I couldn't connect to Ruth. Catherine is not picking. Tony is coming. But meanwhile, I think we can start. June, are you able to chair the meeting?
Good evening.
Good evening.
I hope you can all hear me.
Yes.
Okay, awesome. Maybe we'll just get right ahead. I think it's first important to understand what happened during yesterday's dry runs. Maybe I'll ask Samson to just give us a brief account of what happened, what worked, what did not work for those who are not in attendance, and then we'll pick up from there to define what our tasks are going forward. So maybe Samson or Barbara. Am I audible?
Yes, very much.
Just a minute, fixing my audio.
Okay.
Hello, can you hear me?
Yes.
Okay. I'll give you a brief from what I can remember. From the test run that we did, the issues that we had were some of our avionics weren't fitting in some of the rocket airframes. So this was because either the PCB was too large, or the battery was taking up a lot of space, and we had to find a way to improvise or solve that. Another problem came about with the antennas, the GPS module, and the antenna used for LoRa communication is they don't fit quite well. We don't have space for them, so we requested the airframe team to make to cut like a slot for us, 2 slots for both antennas. 2 rockets are able to be fit, if I remember right. And then the other thing, yeah. So we were looking for a way to go around the issue on our PCBs not fitting into the rocket airframe. When it came to range test and communication, I think that was fine. We were able to receive signal from, well, we just set up to about 20 meters, but yeah, the signal was there.
Excuse me, let me interrupt, Barbara. So who is recording? Because after the meeting, someone has to share the minutes of the meeting on the WhatsApp group. So who is recording?
Sorry, just
So who can volunteer the recording?
Maybe just to ask, is there not an automatic recorder? Because from my end, I can see it's on record. It's recording.
Yes, it's recording. So someone has to write down and share the summary, because you cannot, you see, you cannot play the whole video again, which takes 30 minutes, 1 hour. So you have to summarize summary and put it on the WhatsApp group. So somebody, everybody can catch up within 1 minute.
Okay.
Okay, I'll write it down.
Please don't, Ian. I want to ask the current members. Yes, you can also, yeah, everybody can take note, but yeah, this is a mandate of the team, you see. And okay, let me tell you that this is something missing in this team, the sharing of the information. So we have to, but it's not too late, so we can start now. So I ask the volunteer. Well, it's not a difficult task. So Barbara is saying that what has been observed in the testing yesterday, and she mentioned some issues like a PCB dimension and blah blah blah. So you just list it. Don't need to write a whole sentence, right? You just tick tick tick, list the items. Is it a too difficult task for you?
I think Juna said she'll
Okay.
do the task.
Yes, then please. Sorry, go ahead, Barbara.
I think I finished what I could remember. I was requesting if there's someone else if there's anything I've missed from the dry run yesterday, someone else could add on to it.
That's yesterday.
Samson, kindly come again.
Sorry,
We can't-
can't hear you.
Saying that what Barbara has listed, you can just put it, let's say in a nutshell, is that Wi-Fi transmission was successful. So LoRa transmission was successful. So yeah, so the Wi-Fi both had some issues. So that's what I believe this many the issues around the Wi-Fi board.
I'm sorry, but I can't hear you clearly.
Me either.
I'm in transit. That's why I think I'm not.
Samson, maybe you could write them on the chat because you can't
What
really hear.
Hello?
Hi.
Yes. Okay, could I ask like what were the successful things also during the dry launch? Some of the observations that you guys made.
Okay, I just let you know
Hello.
yes, Samson, you can go ahead later. So the members who are present at the dry run is Samson, Mohammed, and Barbara, Catherine, Safa, and Samir. Yes. So anybody who have opinion, please share.
Hello, am I audible?
Yes.
Yes.
Okay. So the successes of the dry run was, I can say, in terms of powering, video transmission was successful once it was powered. Then we were able to, what can I say? In terms of then the base station was okay, both for the LoRa and Wi-Fi. Then yeah, so we were able to set up the base station, but now we couldn't receive any data since not that was the power issues. As Barbara said, the battery couldn't fit into, even if the battery could fit, the circuit board had some issues. So there was no data transmission. So we can say in terms of successes was, yeah, okay, we were able to upload the code well, everything could work. We could get data from the sensors when we were outside the rocket. But inside the rocket, nothing could be transmitted.
Sorry, Samson, maybe just to understand, when you say the base station was okay, yet the Wi-Fi wasn't working, how did you test that the Wi-Fi was, the base station was okay?
I think when I say Wi-Fi wasn't working, was that the FC, the flight computer, was not transmitting the data, the acceleration, velocity, and everything. That's what was not being transmitted. So the flight computer that has an issue gathering the data, I think the circuit board as a whole. Just
Was the issue with the PCB or
yes,
the code?
that's what I'm saying. Yeah, no, it was an issue with the PCB.
Do you have PCB designs like we can be able to see help in coming up with where the problem might be?
Yeah, okay, if you can brainstorm right now, is when you power, okay, think the second theory I have, like when you power.
Can you share the
MPU
schematics? Can you share the schematics or the PCB image?
Yeah, June, if you're near your laptop.
Let me do that as you continue. Let me send the file.
Also, just a question, like with the issue of the sides, did you like was there like an agreement with the airframe team regarding the size of the avionics bay when you're coming up with the design?
Maybe just to take up that question, Ian. Yes,
we had an issue with aluminum.
The two that were failing was the aluminum ones.
Okay, in fact, they all didn't. Okay, we had two PCBs that could fit into the fiberglass, but the aluminum was like a centimeter short. Even the airframe team confirmed that the diameter that they expected was not what they got after fabricating the aluminum rockets. So we need to reduce our PCBs maybe by 2 centimeters at least.
Oh, and the way you guys are loading, sorry, the way you guys are loading the PCBs onto the airframe, do you have like an avionics bay, or how are you loading them?
There's an avionics bay.
Could you guys please send the images if anyone has?
Okay. Unless I ask from next.
So if from this image I'm seeing the avionics bay itself is able to enter the airframe. It's the PCB that's not.
Yes, once you connect the battery, there's how the battery connector is outside, so it's not possible. It's not possible inserting it with the battery connected. So we had to work on it with the airframe thing to drill maybe some holes on the wood so that the cables will pass through instead of around.
And also, they had designed the avionics bay according to the aluminum and the fiberglass, but the dimension that we had was for the fiberglass. When they were, I don't know what happened when they were trying to design, and the aluminum, the avionics bay and everything was smaller than the dimension that we had expected. But the avionics bay for the other one, like our board was fitting perfectly.
Okay, so if I understood correctly, apart from the circuit, you also need to reduce the avionics bay, the size wise. Is that correct, Safa?
Oh, no, not really. Not really. They had designed the avionics bay according to their dimension of the rocket, so that was okay. I was just pointing out that the avionics bay also had different sizes.
Okay, so these avionics, okay.
Yeah.
This avionics bay is able to enter the aluminum airframe without the PCB.
Yes.
Okay.
So question, when you're redesigning, are we then redesigning specifically only for those that are going to be fitting into the aluminum airframe, or do we make them all standard?
I'd suggest we do it for all. Let's just fabricate 3 smaller PCBs.
Okay,
Okay,
for that,
yeah,
I'd request
sorry.
Maybe
Yeah.
just
I'd
another.
request again the PCB design.
By saying it's on, okay, obviously it's just one design, then fabricating 3 of them. So we only design one. So
Let me interrupt. So I had the question as the same as Ian. So I just want to ask you to share the design for. So this one is for Wi-Fi, right? I understand there are 3 Wi-Fi. Let's say Wi-Fi based flight computer, Wi-Fi based flight computer, Wi-Fi based flight controller, and the LoRa based flight computer. Is it true?
yes, it's 3 Wi-Fi flight controllers, flight computers, and 1 LoRa flight computer.
So I just want to know the association. So there are 2 fiberglass and 2 aluminum. So which LoRa is installed in aluminum or fiberglass?
The LoRa team wanted to use aluminum. I wanted to use fiberglass. Sorry.
LoRa is fiberglass.
Yes.
Like this. So for fiberglass, they don't have a dimension issue.
So for the LoRa team, the issue came about when with the battery connector.
Oh, okay. So
yes.
Okay, there are 2 issues. Let me.
Oh, for the issue of the battery, we had worked on it yesterday. That was kind of exploded now.
Sorry, you're talking about
The battery issue.
battery issue.
Yes.
So the battery fits now.
Yes. We had extended the connection.
Did you try fitting it into the
But
rocket?
yeah, but actually we have to try and fit it again.
Okay, it has not been solved. You didn't test it, right?
Yeah.
Okay, so still, but is it the LoRa?
Yes, for the LoRa, but I think we are going to use the same mechanism for the rest of the PCBs.
Oh, so all the avionics bay has the same issue.
Yes.
Okay. So in that case, oversizing is only for the avionics aluminum body. So my question, Samson, so are you going to refabricate the PCB for fiberglass? Those 2, are you going to refabricate?
Yes. We'll refabricate the PCBs. So I believe that's what you are saying about we do it tomorrow morning.
Well, is it really necessary? I wonder if this can be used without any issue, because there is no issue of oversizing. Do we really need to refabricate? They are working, right?
I thought he suggested that there was an issue with the circuitry, if I'm not wrong.
Is it true?
Maybe he can expound more.
If we fabricate it.
Okay, so there is another issue, like a circuitry issue. So you can tell me what kind of issue they have.
Okay, so once the MPU and BMP are detected in one of the boards, that's that way then there was some error being thrown after that. So
Error.
I've tried searching on it. So we are, yeah, because I believe we are, so the error I think of about pouring, since you're pouring the sensors separately from the ESP, possibly the reason we're getting that error in the code. But once I re-implement the circuit on the breadboard, but pouring it differently, that's what I was doing today when you found me in the workshop. I thought the error was in the code. So, but once I implement everything on the breadboard, but pouring it differently, that is being transmitted to the base station correctly. So I believe it's a hardware issue, not a software issue.
In the sorry, maybe a suggestion. In the PCBs, do you ensure that the grounding is connected for all, even if they are powered differently?
Yeah. The share command.
Okay.
So Samson, it seems you have reached a conclusion, like hardware issue. Could you tell me the precise issue?
I believe, June, are we pouring the sensors with 5 volts or 3 volts?
We were stepping it down to 3.3 volts for the sensors.
For the 3 sensors. Okay, then.
I'm curious actually on that. I'm curious now that you're speaking about that, because as compared to the schematic that is there, how did you power it? How did you power them differently? And moving forward, how do we redesign based off of what you want today?
So on what I was doing on the breadboard today was I power the ESP through the VIN 5 volts. Then from the 3.3 pin of the ESP, I power the sensors. Then since you're using 2 buck converters, then the GPS, we power it with the GPS and the PI for camera. GPS and PI are powered using 1 buck converter, while the sensors are powered from the ESP, and the ESP is powered by the other buck converter. I don't know if you get the picture.
Okay, so maybe just to understand, the GPS and the Raspberry Pi are powered by 5 volts.
By 5 volts from 1 buck converter.
From 1 buck converter. And then the second one powers the ESP.
Yes.
And then the ESP then powers the sensors.
Yeah, the 2 sensors, the BMP and the MPU.
And MPU.
That seems to work when I prototype it.
So John, I think this board seems to be designed by you and Kisaka. And have you found such an issue before?
So the last time we tested them, they worked. So I'm actually very curious as to why they're not working now, because we did.
You actually uploaded the code and the sensors and everything.
Yes, I did. The Friday just before launch was cancelled, while we're finishing up on them.
And there's no need to redesign. You can maybe you just fix the current issue then.
The same board.
Yes, Ruth.
June, I have a question. When you're pairing the PCB, which battery did you use? Which battery?
The 14.8 volt battery, the big one.
14.8. Because I think on Friday, not Friday, I mean Wednesday, we used the 11.1 volts. So I don't know if that could be the issue as well. Because if you use the 14.8 and it worked, because we also put the 11.1 on the LoRa PCB and it did not initialize the sensors. So if you use the 14.8 and it worked, so I think we can also try with the 14.8 and see if it works.
So it might be just a power issue with the battery.
Yeah, probably, because if she used the 14.8 and it worked, so probably the fact that you use the 11.1, that could be the problem.
I'm also curious, had you connected the ejection PCB to the avionics bay, to the flight computer while at it?
Yeah, because the ejection board is the one that is powering actually the flight computer, because the 14.8 volts from the ejection board directly to the
Flight
flight
computer.
computer, then to the back converters, now to the ESPs. So I think if you can try with it before redesigning, it might work.
Speaking of the 14.8 volts, do you have them with you? Last time I know it's Kisaka who had them.
Yes, Kisaka is still the one.
During the dry run, we didn't have the 14 volts. We were using the 11.
Yeah.
But the quantity we have in our possession currently, I don't think can support all the boards. So if it's an power issue, we are suggesting we buy 14.8 volt batteries.
We have them, Samsung.
The batteries are there.
Three, four.
Kisaka has them.
Yeah. We
Have
have like
confirm
four.
Kisaka.
Kisaka has 4 pieces of
14.8 volts batteries.
So I just wonder, what is the purpose of having 11.1?
Maybe just to answer Dr. Aoki, initially it's the 11.1 volt battery is the one we had during the first batch. But when we did, and that actually we carried them from the N2, but when we did our power requirements sheet, we realized that the Nichroma actually required a greater current pool of around 5 amps to initialize. So then we moved to 14.8 volts. I think we'd done those calculations sometime last year, and that informed us moving to the 14.8 volts rather than using the 11.1 volt battery.
Okay. So ideally, we should have 8 pieces, and sorry, not 8, the 5 pieces by adding 1 extra. Do we have 5?
We bought 4 of them. We purchased 4 of them in November, just before launch.
Why just 4? Because we were initially intending to launch 5.
What was the design? What do I remember? Why? It was a supply issue. It was a purchase issue. They only had 4 of them in stock, so then we decided. Sorry.
Yeah. Okay. But still, I'm wondering. So, what happened if we just proceeded to the launch in November? We just had anyway. Yeah. Okay. So for now, we are going to check if this 14.8 volt works, and if it works, we don't need to reproduce these two. It's just a waste of the time, because June says she already confirmed these 2 boards are working, so we don't need to destroy this effort. So
tomorrow, first thing in the morning is to fix the current board.
yes.
Or by then, so we first test the 14 point.
Yeah.
With the 14 volt batteries to confirm it was a power issue. Then I believe it's still, since the current board in the picture is too large, we must I believe we must redesign one board.
By redesign, you mean just reduce the size, right?
By changing the size, I believe we'll have to also change the routes and everything. The current.
Okay, where is GitHub link? Can you share the PCB design?
Let me share with you. I think I pushed it towards the end of last year. Let me send it.
Okay.
Oh, Samson.
Yes.
You're mentioning that we need to redesign the PCB for the aluminum airframe.
Yeah. Because even if we try and trim the edges as much as possible, I believe it won't fit.
Yeah, that's true.
The board in the picture is quite huge.
Can we use this board in the picture in the fiberglass body instead? Because it was a bit bigger.
Yeah, unless we test it. There's only one way to find out. We try and fit it manually tomorrow, then it fits well and good.
All right.
But you know, okay, yeah.
Oh, so was it the Safa or Ruth who was speaking?
Ruth.
Ruth. Okay. So you were suggesting that we are going to swap, like.
Yeah, because the fiberglass airframe it's like one dimension bigger than the aluminum ones. So if it's still big, and even after trimming it, you can just like repeat it and put it in the aluminum one.
Okay.
But I'm not sure if the others will fit in the aluminum one as well.
My question, so Laura, is this PCB smaller than Wi-Fi?
Okay, yeah, the LoRa one is actually, I think it's among the slides. It's smaller.
I see. I have seen somewhere. Yeah. Okay. Yeah. I think, yeah, there are some clearance. Okay. Apparently we have clearance. Yes. So that works. So in that case, okay.
I still have a question.
Yes.
If the battery is already too large, and that was the 11.1 volt battery that you tested with,
no, it's 14.8.
Oh, it's a 14.8 volt that was too large.
Yeah, but I think Safa had mentioned it. There's a way that we had planned to like try to fit it, to use connectors instead of fitting it directly to the XT60 connector. So like we extend the wires and then.
So the issue is the XT60.
Yeah, in a way it was kind of protruding. What can I say? It makes it like be like higher. Like it makes it, what do I say?
Yeah, I get.
I have a concern when we're rerouting. When we're redoing the redesigning the PCBs. I'd like to point out that there was a board we were also trying to fit, and aside from the PCB being broad, the sensors were also getting damaged when you try and shove it in. So if we go with the route for redesigning, when routing, I'd suggest that you try to place the sensors in the center. Try to get them to the center as close as possible.
Which sensor particularly?
Not like, yeah. Which sensors? Let me look at the email. Let me the email.
To answer Barbara's question, I think the issue is that we were trying to fit in the avionics bay together with the battery at the same time. That's why the sensors were damaged. But if we go with Safa's design, we can save the sensors and we don't have to reroute how the sensors have been placed on the PCB.
Oh, excuse me. Could you elaborate the Safa's method again?
Okay, on the avionics bay, there are two circular joints holding the entire bay.
Yeah.
The ones on the top.
Yeah.
So Anne had suggested if we are able to remove from one side and we attach the battery directly next to the ejection PCB, then we will not have an issue with spacing, since the required amount of space needed for the avionics bay is actually enough to fit the battery if it is fitted along the entire avionics bay. That is what we were suggesting.
Okay, so you have enough space for having the battery this side.
Yes,
And is this side engine side or nose cone side?
nose cone side.
Nose cone side. Okay, so you have a battery here and you have a parachute here.
Yes.
Okay, okay. And okay, ejection piston. Okay, okay. Okay.
Yeah, because the battery has to be connected to the ejection PCB first.
Mhm.
So the ejection PCB will be on top of, like, above the avionics bay.
Yeah, yeah. It's here.
It's not, yeah, it's the one that,
Or it's
yeah,
that
it's
one that's
that
been highlighted.
Yes, yes, yes.
Yes.
If the battery is on the other side, can you just drill a hole through the avionics bay and put the wires below or something instead of passing it through the XT60 at the top?
Uh-huh. Like, yeah, we drill. Is it an option? Like we drill.
Because I'm thinking if the okay, if the battery is on the other side, you can even do the XT60 on the bottom of the PCB. Then the hole that you drill, the XT60 goes through it and is connected on the other side to the battery. If it's not, you can just solder, but that will be like almost a loose connection, soldering wires at the bottom that go through the hole.
We can also do that. Maybe we look for like a carpenter somewhere.
I'm thinking the drills at IPIC, I think they can do their job.
Yeah, yeah, that's an easy one. Rapid too. You have a drilling machine.
Yeah.
Yeah, it's an easy job.
Oh, and also, oh wait, sorry. Even after drilling, I think we had tried to look at that method also during the dry run. Even if we're still going to drill, we are still going to need like an extra connector because still after connecting the top part is still going to be higher than I don't know how to explain it, but still going to bring some issues.
Actually, tell me the issue.
With the suggestion, I wouldn't use the XT60 as it is right now at the top. You'd find a way to create like a solder at the bottom, maybe either some wires, or if these XT60 can be able to, when it's soldered on the bottom and protruded on the other side, you can be able to enter the battery's XT60, whether it's male or female, then you can do that option of the XT60 being connected on the other side.
So maybe if I'm getting your idea correctly, have the ejection PCB almost flipped to the bottom so that the XT60 is actually on the bottom, but everything else is on the top.
Yeah, the XT60 will be at the bottom where the hole will be, right?
Okay.
So in that hole, you can make it big enough. That hole that will be at the bottom, you can make it big enough such that an XT60 connection can happen there. So if you make the diameter big enough for connection of XT60s and then solder the XT60 at the bottom, you can be able to connect the battery on the other side, right?
Oh, okay, I get you now. That will work.
Yeah, makes sense.
Can try that.
Okay.
Oh, and also, I think I put across a point vibaya. So what I meant is there was like we can't use the LoRa PCB on an aluminium body.
Why?
because you have an external antenna,
Mhm.
and it will probably affect how it's going to work.
So aluminum, so you have this aluminum interferes, antenna interferes aluminum.
The aluminum interferes with the antenna, yeah. So I think they can still reroute, we can still reroute the PCBs that will be going to the aluminum bodies. Yeah. So 2 of the PCBs.
I have
The
a
effect
question.
is not reciprocated on the Wi-Fi also. That's a question.
Do we have any external antennas, June, on the Wi-Fi?
Yeah, we do. The UFL antennas. But the question is maybe to also piggyback on the questions you're asking. Like your antenna, is it on the body of the rocket, or how is it attached exactly?
Yeah, it will be on the body of the rocket.
And a suggestion Professor Chola had made yesterday would be, not yesterday, on Tuesday, would be to more or less like isolate the antenna between the antenna and the aluminium, have like or like a casing, something that is not conductive.
Okay, what I meant was, because I think we are still redesigning we are still rerouting the PCB for the one that will be used in the aluminum body, right? Because it's a bit on the bigger side.
Yes.
So we can just make like 2 of them,
Mhm.
because of the challenges that might be faced with that.
Okay, so mhm. Okay, so let me check. Oh, this is the photos. Can I find a GitHub link? I'm still waiting. June, are you able to share?
Oh, yes. Let me share. Sorry, I got carried away.
No problem. And also maybe meanwhile, so we need to documentate, like you see, Samsung even didn't know it should be done with the 14.8 volt. So this information is crucial. So we have to documentate it. So at the end of the day, or by the end of tomorrow, we have to documentate everything, like a tutorial, or not a tutorial, it's it's a manual of how to activate this system.
And we talk about the connectors, because we believe no one's mentioning it, because we've not fabricated the connectors between the injection board and the flight computer.
What do you mean? Like there is no connection?
Like you see, we are using, are they called JST connectors? Because so far we are soldering directly the connectors. So will you also do that for the final flight computer? Or if someone can comment, I believe, and Kisaka in the meeting, he was to help hit them. Or June, can you comment on the connectors?
Yeah, sure. We have a couple of GSTs in the box, and the idea was we got them as just the connectors without the wires. So the idea was to connect the EW into the connectors and create like a JST to JST connector. So basically to connect the flight computer to the ejection board. I did a couple, I think like 5 together with a new intern. I think she's called Esther. So we're able to do a couple of them on Tuesday. Yeah, on Tuesday. the idea was to also get Harun to buy more, but unfortunately there weren't so many. So I'm hoping in the new BOM, because that would be what we'd do, just crimp, more, is it crimping really? More like crimping an AWG into the connector, the GST connector.
The GST connectors are used for which connections?
See, like for instance, in the current photo we're having, you see there's a white GST on the ejection.
Yeah.
And then now it goes in, it's what powers the flight computer. And also the flight computer powers there's a GST connector between the flight computer and the ejection PCB that provides the power, and another external one that provides the power to power the micro back to the ejection PCB from the ESP. That makes sense.
So just
So,
to
and the
confirm,
data,
sorry, yeah, go ahead.
and the data wire that comes from the flight computer to the ejection PCB is also using the GST.
Yeah, so the power to the flight computer and the nichrome wire to the ejection from the flight computer, both of them are using GST connectors.
How about the cable that comes from the transistors to the flight control, to the flight computer?
Okay, so the connectors that we needed were, if I can count correctly, there are 1, 2, 3, 4. We need 4 connectors for each avionics bay. From the injection board to power the flight computer, and the activation pin from the ESP back to the injection board, and the last one is from the flight computer to power the Raspberry Pi of the camera. So in total, for each avionics bay, we'll have, okay, that's for the Wi-Fi. Don't know LoRa. For LoRa, it's 3 because they don't have camera. So in total, we'll need, if I can count correctly, those are 4 times 3, 12, 12 plus 3, 15. So we need a total of 15 connectors. So how many, John, you said, how many connectors did you fabricate in Chubut? And where are they located? Because so far we've been soldering directly. We've not used the connectors.
As I was leaving, I left Kisaka with the instructions of where they were, but I left them in the green, the first box in the green space. The thing that we're storing, the green thing we're storing our things in. I forget the name of it. The metallic case we're using to store our things. In the first box, on the first drawer.
So we need to fabricate 6 more.
Yeah, ideally, yes.
Oh, you only have Gavers. Where is the design file?
Okay, let me add that. I think seconds. Let me push it.
Yes. Yes.
Okay. Oh, Oh, okay, let me push it.
What about just sharing the EZDA link? It was all done. Or you used the card?
I think you have to individually, remember the issue we had, you have to individually add everyone. Let me just.
Private.
Yeah.
Oh, is it the one that is in my account name? The one that we were designing?
Yes.
Let me try and share the link and contact me.
Meanwhile, do you have enough items to start fabricating PCBs? HCl, PCB boards, connectors.
In terms of chemicals, yeah, we bought a few. Is it plastic?
Is this enough? We are
Then
making some.
yes, it should be enough.
Should be enough.
The
Okay.
issue may be the copper clads, but
Mhm.
I believe today I saw there are some two copper clads, so we can use those.
Do you have some copper class?
Yeah, there were two copper clads I saw in the workshop, in the prototyping.
Okay, 2 copper class. If we are to buy copper class, is it easily purchasable? Can we buy easily in Georgia?
I can call someone to confirm. There's someone who sells them in Georgia, so I can
Okay,
confirm after
just
that.
yeah, please confirm, because we don't want to waste time. If something is wrong, we have to refabricate it. So yeah, let's have some extra.
Okay, let me call them right now.
Okay, and also connectors, do you have enough?
I believe June can after that. June, do you have enough connectors?
I said, sorry, I said, I'd suggest we add a couple more, maybe around 10 more, just in case things go awry. But ideally, we have a couple that you can just add. Doesn't have.
Can we buy it in Georgia?
Yes, I guess so. Maybe Samuel, as you're asking, Samson, as you're asking for the copper clad from, I'm guessing some types, you could also ask for this JST, the 2-pin JST. But I also know that Nerokas has, so maybe in case anyone is going to Ika tomorrow morning, they can pick them.
Okay, so I think it's safer. So we can just have 2-pin JST connector. So whoever who can pass the Nerokas in the morning, they can just buy and bring. Anybody who can pass the Nerokas tomorrow morning?
So copper clad you can obtain from Georgia. The guy says he has single-sided copper clad.
Okay. Connectors, did you confirm?
Not really, because June, name of the connectors is just JST, male and female.
I've written it on the group, 2-pin JST. They usually come in a pair, male and female.
Okay. Meanwhile, any other issues?
There are no JST connectors. 2-pin. They're only available at 3-pin and 5-pin. So I think
In that case, we can just 3 by 3 pins and kill. We don't use a 1 pin, so that it can become a 2-pin connector. Just an idea.
yeah, if it's possible, yeah, you can implement that. You can drill an extra hole for each PCB where the connectors were supposed to go.
So maybe let me ask you, John.
Do that. Sorry.
Yeah.
I've just sent a link that has the JST connectors.
Okay, the Nerokas. Okay.
Yeah, they're in stock. Yes, sir.
Oh, so just to clarify, so we were discussing the number of connectors we require on one PCB. So is it 6 you mentioned?
We need 3 males
Uh-huh.
per PCB and the corresponding females. So we only need 3 per PCB because they
3,
come in a
okay,
pair. Yeah.
per PCB. So we have to have 4. So it becomes, we need a 12 connectors. And in your intuition, do you have 12 at IPIC?
We'd probably have around 5 till 6. You know, we need maybe just get the same number that we require.
Okay,
Because some of them.
Okay.
Yeah.
So apparently we need this one. So there anyone who is coming from that side, Tika? No? Or do you know someone who is coming from that side, who is living? No students is living in Tika? Or is it a secret?
I can go and pick. It's not far.
It's not far?
Yeah.
Yeah, are you sure? Yeah, okay, yeah. If you can do it, I appreciate. So okay, you can just get let's say, yeah, just buy 12 pieces at least.
Okay.
Yes, and yeah, I can make a payment. So just let me know, and I'll send.
Okay.
Okay, thank you.
Maybe, sir, maybe we could make a new list of the BM materials because I'm almost sure probably people will probably need more things than just the JS.
Okay, yeah, true. I'm a bit scared. Like, you see, okay, I think Kisaka saying like he can bring the 4 pieces. I trust him, but there must be some items missing because last time we have listed so many items. Yeah, and I just wonder, do you really need to have something else?
Maybe just to speak on something like the flash memory, I'm pretty sure we'll need more because they are SMD, so we can't desolder. It might be difficult to desolder. Then resolder them on the new PCBs. So we probably need to get more. And there's a concern that not Samsung, but Barbara mentioned of the sensors getting deformed. I'm wondering if they're all working correctly now.
So,
if
yeah, but Barbara, can you report which sensor is broken so that we can, Mohammed can buy it tomorrow morning and bring it for us? Here we have a list of sensors. So which one?
No sensor is broken. They were just like about to. Like we noticed they were being pushed against the avionics, the airframe. So yeah, we stopped pushing against it. I think the only thing that was damaged was but this is another PCB. The only thing that was damaged was an antenna.
Okay.
I don't know if Sophia solved it.
Okay, anyway, so anybody can let me know which items we require to purchase.
Oh, by the way, the GPS requires antennas.
Come again? Samsung?
Oh, the GPS requires antennas.
GPS requires antenna, okay.
Like in that picture, you see that there is but when the guy who brought the GPS, they didn't get the antennas. So, like currently, the LoRa one is the only one that had an antenna. But I was able to get some antennas from the, like only one from a previous NRF module. Yeah.
Oh, so.
Sorry. Yes.
Yeah, so we just need, maybe, I don't know if those antennas can be purchased individually.
Antenna like this one? Or which type of antenna?
Like you see that GPS, in the next to the back converter, between the back converter and the ejection belt. In the current picture, there's some antenna there.
This
Yeah,
one?
where you're hovering there. Yeah. Now.
Oh, this
yeah,
one,
you
this one.
see-
Okay, okay, okay.
Yeah, that one. Yeah.
So how many do you need?
We have 3 GPS, so those are okay. Just let's say 4.
But you have one already.
Oh, okay. But so we have one from an NRF. So yeah. So okay. According to route, the antenna they currently have will capture the satellite networks for the GPS even inside the room. But for the NRF antenna that I tried with inside someone's room, it couldn't ping the satellite. It couldn't get the network. So I don't know if there's a relation between power or something with that type of antenna. If someone
Okay.
has ever worked with that type of GPS.
Oh. Somebody?
But wouldn't they be outside? They're not going to be collocated. My understanding was would be fitting the GPS outside the body tube.
I don't think it's possible to fit it outside. Like,
Right.
how can you fit that antenna from the outside?
But you have the UFL, the SMA to UFL extenders, you know.
Oh, okay.
Okay, the GPS does not have an SMA connector. It is just a UFL, so you just have we cannot extend it, so it needs to be inside the body. It cannot be able to go outside. Even the orientation that is with right now, it needs to be like currently it's vertical. So when it is vertical, you can't fit it inside the body of the avionics bay. I mean of the airframe. So you have to slant it horizontally. Yeah, so it is impossible to have it outside.
Could we fit the UFL antennas instead? Okay, but I think we could do some tests and see once it's inside the body of the rocket, because Ian, if I'm not wrong, last year we fit them outside, right?
Yes, they were outside.
Oh, just asking. So if we put this chip, the GPS chip, outside the rocket body, we don't need an antenna.
We
You
still
still
need
do.
the concern is whether the antenna is inside or outside.
Sorry, I didn't get it. So yes or no? So do we need or we don't need?
The other antenna is attached to the GPS.
Yes, attached to GPS. Yes. So is it a mandatory? Is it necessary to have this one?
Yes, for a reliable connection, you need the antenna for it to be able to lock easily to satellites.
Okay. 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 There are two issues. One, to purchase antenna because we don't have any, right?
Yeah, I saw Nerokas has some in store. I sent the
Okay.
link.
Okay. So kindly, moment. Let me check. So Mohammed, take note, or maybe just create a list of items.
I have a question. How do you fit the avionics bay into the rocket? Is it how we were doing it last time, or if I'm not wrong, I saw nowadays the airframe is split into two. Anyone?
Fitting it's in two portions, so fitting it from the bottom, which is
It's in two
much
portions.
Yeah.
So the avionics bay is at the center, right? Or
not really close to the actually very close to the motors because it's the fact that the lower body. Okay, actually close, just around the middle. Yes.
So
Okay,
this,
if I understand, okay.
yeah, this is illustration. So which airframe team has told me. So for the fiberglass, you have kind of two components or three components, and or let's say two components, like a top and bottom. It can be split into two, and for the aluminum, it can be split into three: top, mid, bottom.
So, okay, because I'm thinking for the antennas, depending on where the avionics bay will be, I'm not sure where. Okay, if the GPS module is close to either exits, whether it's close to the top or the bottom, you can first, when you drill a hole on the body, you can enter the SMA connector first through the hole. Then, as you enter your avionics bay, when it reaches the GPS location, you can clip in the SMA connector, then continue pushing it a little bit, depending on the length of the antenna, and then you'll be done. The antenna itself will be outside, and the SMA connector will be inside. But it all depends on where the avionics bay is placed.
Ian, so for the current GPS modules, they're the Neo 7M. So the patch antenna is like actually permanently fitted on the body of it does not have a SMA connector. It is just fit on the
Or like
surface of
the GPS comes with the antenna direct.
Yeah, it is like attached to it. It's not like the ones for Neo 6M where it has an SMA connector. It is just, it's compact to the body. Yes.
Are all the PCBs using the Neo 7?
Yes, those are the ones that we got.
How come they don't have antennas?
How come they don't have antennas?
Well, okay, the antennas that we put, okay, it does have an antenna, but it's like it's attached to the surface of the GPS itself. But now the external antenna that you are mentioning, it's just to enable it to like ping faster. Yeah.
So if it doesn't have an SMA connector, how are you planning to connect it to the antenna?
It has a UFL connector. So that's how we connected the black antenna here on the GPS.
Like a small UFL connector.
Yeah. Okay,
That's
let me share
the one I'm suggesting.
Okay.
Because, okay, if I'm seeing it correctly, the one on the rockers, if they'll have whatever they post here, it's like they say it's 14 centimeters long, the wire. So if you're able to enter that cable through the hole you'll drill, then when you drill that hole, then enter that cable through there. As you enter your avionics bay, when it reaches at the top, just at the entryway, when it reaches the GPS, you just pin in the UFL connector to where the GPS UFL connector is, then continue entering your avionics bay. Because I'm thinking 14 centimeters is long. It's like half the length of that avionics bay, if I'm not wrong. Is the one I've sent on WhatsApp, is it the one you're talking about, right?
I've also sent a link. The one we use is the one that I've sent, shared the link.
Okay. It's redirecting me to eBay. Oh, that's the connector you're talking about.
Yeah, it does not have an SMA connector.
Oh, no, that's the UFL.
I think so.
Wait.
Ruth, if I'm not wrong, I saw you purchased a connector, a connector extender from SMA to UFL on from Pixel Electric. Yeah,
Yes, yes.
have they arrived yet?
Maybe I check with them tomorrow. Actually, I wanted to mention that according to Dr. Oki's recommendation yesterday, where he suggested for how we're connecting the ejection board to the ejection circuit, to the ejection circuit, we got the XT60 connectors for that case. So I ordered them, so probably they'll be there tomorrow.
Sorry, how we're pairing what to what?
You know, now there's there's a wire connection from the ejection board now to the circuit that Eric built, the one that has the crimson powder. So usually we're just like tying the wires together, but Dr. Oki suggested that we use XT60 connectors instead. So we just solder the wires to one female and then another to the other male, and then we just connect them together instead of actually tying the wires together by hand manually or screwing the
Oh, okay, I see. So if that's the case, then we don't have a problem with antennas, do we? If there's that pigtail, the one that's already been ordered from Pixel.
Well, for the semiconductors were for the LoRa chips, because we ruined some of them yesterday while trying to fit the avionics bay into the body. So some of them were cut, so I had to buy other ones. Yeah.
I'm curious, does the SMA go to the ESPM? Exactly where does that SMA end go to?
The SMA end goes to the LoRa chip, to the LoRa. The LoRa has an SMA connector on the, yeah.
I'm not wrong, Kisaka had purchased some and he'd said he still had some of them, those, and let me ask him.
Yeah.
He still has those extenders.
Yes. Okay, so I think now I want to clarify for antenna issue. Oh, where is it? Okay. So so there are two types of antenna. One, the one is which is used for LoRa and Wi-Fi communication, telemetry, and antenna for GPS. So for the four PCBs are using the same GPS chip. Is it right?
Yes.
Okay. Okay. So GPS module. So is it this one, the Neo 7M?
Yep, the module is Neo 7M.
Okay, Neo 7M, all of them. So okay, so this one, so you need a SMA antenna. Did we conclude, or we are still discussing? Hello, nobody has an answer for it? So do we need a SMA connector which is attached here? We are not certain.
June was talking about some extenders that were bought. What extenders were you talking about?
Okay, so June is confirming Kisaka.
Basically, but then I'm on chat with Kisaka and he says it was UFL to SMA one. So the current end that we are having on the current antenna, the GPS antenna, what you can see down there, just after the antenna stuff, the thing that looks like a BNC is the SMA connector, and then we have like a small one that's the UFL connector. So I'd initially thought we had an SMA to SMA extender, so that would fit directly to the kind of antenna you were mentioning, Ian. But since it's a UFL to SMA and the current GPS does not have a UFL and it has an SMA end, we can try and see if we can get SMA to SMA extenders. So then that way it connects. But then where would that go to? Kisaka is correcting me and telling me it's not SMA to SMA, it's a UFL to SMA, which does not fit our current need. Yeah.
So we have to buy SMA to SMA extender?
So that I can speak and tell them the antenna actually work. Sisi ndo tulifanya ujinga wetu tukaweka antenna ya LoRa ikakuwa more efficient. Sisi hata watuelewi. Oh, sorry.
Ideally, yes, we need an SMA to SMA connect. Though.
Oh, sorry.
Are those possible to get?
Yeah, that's the question.
Let me check on Pixel. I think Pixel had a wider variety of things to get. Let me check from Pixel in a minute.
Then my other question will be like the new Neo 7, the way it is right now, is it possible once it's inserted into either fiberglass or the aluminum one, is it able to lock onto the satellites based on the antenna that it has on top? Or has someone been able to test that? If it's not gonna be possible, my other question would be, is it based on the circuitry we have right now, would it be possible to directly just replace the Neo 7 with something like a Neo 6 that has an external antenna that can be able to be placed outside a normal GPS antenna?
The pins won't match. The pins for Neo 6 and Neo 7 are not the same. Like VCC and ground are at different positions, so it won't be possible.
And have you been able to test the Neo 7 if it's able to connect directly, like without any issue?
Today I tried with an antenna. Once I get back at home, I'll try without the antenna. If it connects, then well and good.
Yeah, because I'm thinking if it will fail, we can just, when people are redesigning the circuitry to a smaller one, you just change the GPS pins and implement a GPS that can work like a Neo 6 with external antenna. If you can be able to ascertain by the end of the day, by tomorrow morning, I think.
Sure, I'll let you know.
So we have at the moment we are not certain if Neo 7 works. or if any other GPS works.
Okay, for the drone test, the board that we used, we were using the Neo 6, and it worked perfectly.
So
It was
why
able
don't
to.
So now you are changing to Neo 7.
I don't know when the change happened in fact also, but yeah, I know the current board is using this one.
If I can answer that, we purchased the Neo 7Ms because the Neo 6Ms were not available.
So you haven't purchased the Neo 6 when you were preparing for the launch in November.
We had purchased the Neo 7Ms. These are the ones we bought last year.
Oh, Neo 7 was purchased in last year.
Yeah.
Because I have since you have purchased something today. Was it antenna? Let me check. You have been requesting something today.
Yes. We got the antenna, the SMA to UFL connectors. That was for because once we used yesterday during the dry run, it got cut. Yeah.
Oh, so this was antenna.
Yeah, they were just extenders. They're just connectors
Is
from
this
the
one?
LoRa.
Okay. For the LoRa. Okay. 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 Now, okay, I got one answer. So, for LoRa, yes, for LoRa, the antenna for LoRa Wi-Fi is this one, IPX2 SMA. Okay, let's say this is a cable. Okay, anyway. So you have never but it's funny, like you have purchased the Neo 7 and have you tested Neo 7?
Yes, I did. I remember we did it with Kisaka. Was it Kisaka really? It worked, but I think what debunking on the issue is the fact that this was an open environment. So then the concern I think from Samsung is when it's in a closed environment, they usually tend to have issues in connecting, in latching to the satellite.
Okay.
So I think the idea was to just extend the antenna, so then that way you have a greater pool from which it can connect from.
Okay. Okay, so Nerocas, Neo 6.
Ruth, maybe just to ask, is the current antenna, the SMA, a male or a female on the Neo 7?
The Neo 7 doesn't have an SMA connector.
The gold thing?
No.
Oh, okay.
Neo 7, yeah.
Male.
It's male.
Yeah.
Okay. Thank you.
Okay, because Nerocas seems to have Neo 6. So we need to make
I'd suggest you purchase a couple.
Okay, so I think we need to make a decision about the antenna for the GPS. I think it's not realistic start finding or looking for a store if nobody has purchased it before.
Yeah, I think it's going to be hard to find antennas for GPS, the ones that have that connector. I will suggest we try, for the PCBs that will be changed, we try implement the Neo 6. We can get a couple. The guy who's going to Nerokas.
Okay. So the Mohammed is going to buy 4 sets of Neo 6. And also, in that case, is this coming with this antenna? Yeah, it comes with this. So is it enough? We don't need any.
Which one?
Like we need a chip and we need an antenna. So that's all.
Yes. But I will also suggest it depends with the length of the antenna that the GPS comes with. Some come with very short antenna.
Okay. So in that case, if they separately sell, I think we should purchase the GPS chip, this one, and the antenna itself. So Ian suggested the 14 centimeter.
Yeah, and maybe you could review what I've just sent on the WhatsApp group, because so I think it would still be easier to just get the antennas.
And you'll have to adjust your power requirements also. Active antennas require
more power.
Use
True.
power, yeah.
Okay, I can just go with the Neo 6.
Oh, this is the active antenna. So yeah, that's good progress. Then the antenna for LoRa or Wi-Fi. So the LoRa, so you have purchased this one. This is not the antenna. Is this the antenna?
No, they're not. They're just connectors.
Yeah, this is a connector. So you already have a one antenna for LoRa.
Yeah, we have the antennas.
Which antenna?
It is the same one that is used on the GPS, the same as the one used on the GPS.
And should it be placed outside?
Yes, it will be placed outside.
Okay. So is it something you have been communicating with Airframe? So you need to add slots for.
Yeah, we did communicate with them, and
okay. So in that case,
we were first to figure out how we are going to place the avionics base so that they can be able to drill the hole for the antenna.
Okay. Do you already have the antennas for LoRa?
Yes, we do.
Okay. So it's a UFL. So we have it. Then for the Wi-Fi, do you need an antenna? For Wi-Fi?
At the beginning of the attachment, it was like we were to have a wraparound antenna, but I believe due to some issues that John, I believe you're better to explain why we switched from the wraparound antenna, but we believe it is some fabrication issues. So I think we'll have to go without an antenna. But during the drone test, we didn't have an antenna, and we managed to achieve a distance of around, was it 1.5, 1.6, or 1.7 kilometers. So even without the antenna on board the rocket, I believe we'll get data up to the distance, up to that distance.
So we don't need. My question is, which antenna do you need? Or we don't need any antenna?
Okay, up to today, we've not used any antenna. So John's still in the meeting. Because there are plans of using to extend the ESP antenna, but up to now, no one's done it. So I thought like we will just go without the antenna.
You guys are using the default patch antenna on the ESP, right?
Yeah, just then that comes with the ESP.
Do the ESPs that you're using, do they come with like a connector?
No. We tried to search for those ESPs, but we couldn't find any. So that's why. Okay, we didn't bother even to. Okay, I believe there's a way where how you could scratch the antenna on the ESP, such that you can extend with your own antenna. So we've not done that since the results were satisfactory. Just even without the antenna, we achieved quite a range. So we weighed between the risks of scratching the ESPs and placing our custom antennas with the benefits of just going without an antenna. So I'm pretty confident we'll get to by the time the rocket reaches apogee, we'll still have better transmission.
Which development board exactly are you guys using?
This one, right?
Sorry.
This is ESP32, double room 32.
Okay.
Oh, well, so I think Jun is the best person to ask. So are you still here? Oh, Kisaka, yeah, welcome. Can you talk? Or other telecommunication colleagues? What's your position? So Kisaka has an audio issue, so
Okay, no problem. My last suggestion will be if we can have like a brief overview of exactly what people are going to be doing tomorrow.
Yeah,
that will help.
Yeah, go ahead, everyone.
Pardon?
So I was saying like if someone can or anyone can list us through the things that are crucial for tomorrow, like things that are supposed to be done tomorrow, so that everyone can have an idea of exactly what's going to happen tomorrow and the steps or something, so that we're all on the same page.
Okay, in terms of hardware first, we will need to do the pop test. Then in terms of the PCB, okay, that's in terms of test, we'll need to do the pop test. In terms of hardware, the PCBs, we first test the existing PCBs fully, because personally testing them today, and throughout since the dry run, they were not satisfactory. So that I was pushing just fabricate one quickly tomorrow, or as I suggested Dr. Oki to use board, but okay. So first we confirm the work we did on the current PCB is still satisfactory, that we can still use the current PCB. So that in terms of how we will do that, it's once the batteries come, and Ruth suggested it just may be a power issue. So once the first thing first, we receive the battery, then connect the battery, see if it was a power issue. If it was not, we try checking. Okay, though continuity is okay. So okay, we just resolder any weak components and such. Then if still there's an issue, then I believe we'll have to fabricate a new PCB. But hopefully we don't get to that. Then for the huge PCB, we try and trim them. If after trimming and we try fitting, if it doesn't fit, then yeah, we'll have, okay, I think overnight someone should try, just to be safe, overnight someone should try and design a smaller PCB. That would be my suggestion. I'll personally try designing my own and putting it, so that tomorrow we can fabricate one in case it comes to that. Then apart from that,
Oh, okay.
yeah,
So
then
yeah, just let me interrupt. So the Kisaka is typing on the chat box, and yeah, so most of the things has been mentioned by Samson, and particularly I tried to assign who is going to redesign the PCB. So so far it seems nobody has shared the design file. I requested the June, but it seems it's not happening. So Kisaka, you have the design file, right? On the chat box, you can reply.
I think yeah, personally, okay, I started the group, so I added Kisaka in June.
You started a group, another group.
No, not WhatsApp, like on EZDA, like I think it usually works in group. You know, like work groups or something, like people who, yeah, to collaborate on designing the PCB. So there's some work group on EZDA that consisted of me, Kisaka, and June.
Okay. Well, so my point is the PCB design is not a task for tomorrow. It's the task for today. So we are starting the PCB fabrication at 9 tomorrow morning. So we need to have the design by then.
Yeah, just when I get access to my laptop immediately, I'll share everything.
Yeah. Okay, so okay, yeah, just go ahead. So sorry to interrupt.
In terms of, saying in terms of hardware testing, yeah, we believe, in terms, so after designing it, so maybe after that's for, so 2 PCBs can fit. So those that fit, we should make sure they work, and that they can transmit data from inside the rocket. I'll try contacting Wadime, Jeremiah, or Anne, see if one of them is available to help us insert the avionics, or anyone in our team that can insert the avionics bay inside the rocket. Then, like, we just try transmitting data from inside the rocket. Once we manage to transmit data from inside the rocket over Wi-Fi, then I believe, yeah, personally, I'll be satisfied that the system is working. Then, we're into software. In terms of software, the base station is complete, so there's no issue there. So software will just be in terms of firmware, running simulations. So it's just in terms of running simulations, passing demo data. I'll be in charge of that. So in passing demo data through the firmware to see if the state machine works appropriately. Ian, will you be available tomorrow? Because I believe I'll need some help with the state machine.
Yes, I'll be coming tomorrow.
Yeah.
Okay. So yeah, so since we are using code from N2, so the only thing that I added was just GPS and a few other bits, but most of it is from N2, so I don't understand the state machine fully, so it might be there. So yeah, so passing in terms of software, just passing data through to see if the state changes. I've already created the how you can pass the demo data, so it's just modifying the state machine. So that's okay. That's in terms of software. Yeah, then pop test. Now in terms of pop test.
Oh, okay. So stop. So let me stop. And so you have elaborated our tasks. So let me go one by one. So Samson, what you particularly you are going to do tomorrow? I'm gonna ask you one by one.
Okay. I'll start with firmware. Like, okay. It depends with the manpower. If we have enough people for PCB fabrication, I won't handle PCB fabrication. But if you don't have, I can help with the ironing and etching and drilling. So yeah, so that's okay. I think first we should confirm the number of people who are there tomorrow, so as to know where I can assign myself.
Okay, so let me start. Ruth, what are you going to do tomorrow?
Unfortunately, I won't be available tomorrow. Yeah.
Okay.
But I'll help where I can. Yeah.
Okay, so let me go through. Barbara, what are you going to do tomorrow?
I can help with either soldering or pop test. I'm available mostly in the morning from 10, but I have a class in the afternoon.
Okay.
Yeah.
Kisaka, you can type. Apparently, what you have described is not your task because you cannot do everything. And purchase of components is done by Mohammed. Pop test is done by Eric. So you just describe what you're going to do. PCB. No, design is today. So for tomorrow, should be fabrication, right? If fabrication does it makes sense. Do you know what I mean? So we have to complete everything by tomorrow. So we need to have a design by today. We are going to make it by tomorrow. So that's the order. So okay, good. Thank you. Eric, pop test. Are you still there, Eric? Eric, you can go ahead.
Yeah. Hello?
Yes.
Can anyone hear me?
Yes.
Yeah, I will be doing the pop test tomorrow. Yeah, I'll be handling that.
Also, you have to make sure the other tasks. What are the remaining?
There's something you said. Since we have to do everything tomorrow, after the test, we'll also be doing the assembly of the 5 ejection mechanisms. Yeah, I'll do that.
Okay, thank you. Tony?
Hello.
Yes.
So I'll be doing the pop test and also help with the PCB fabrication.
Oh, good. Thank you. Catherine?
I will assist with the PCB fabrication.
Great. Saka, oh, yeah. Safa?
Unfortunately, tomorrow I also won't be available, just like Ruth, because we have an internship which currently tomorrow we can't be away.
Okay.
Maybe, but in the evening we might also come late.
Okay. All right. Thank you. So, okay, and so in that case, I think the Samsung needs to focus on the firmware, and Barbara, yes, soldering PCB fabrication. So yeah. So we have kind of manpower, so I appreciate.
Okay, so in that case, from around 10, focus on the on making sure the firmware detects apogee. Once apogee is detected, it ignites the Simpson. Then from there, hopefully, from the results of the pop test, we'll conclude that the parachute will unfold. And in that case, recovery will be successful.
Okay, can we start 9 or 10?
I believe 10, because the workshops open at 9 or 10, and the workshops open.
Oh, workshop, is it the workshop or IPIC?
IPIC.
IPIC opens at 8:30.
Then you can start at 9.
Okay, so at 9, yeah. Fine, so the Kisaka needs to share your design by 9 so that we can start at 9. So Samir is asking, there is a Steve, so we can ask Steve to help the publication, yeah. Okay, thank you, Steve. So ideally, we want to complete in the morning, the PCB fabrication and the test, everything in the afternoon, and even the assembly to the avionics board, avionics bay. Ian, do you have any advice for us?
Oh, sorry. I would suggest that we try try and ensure everything works out in the end, especially the recovery mechanism. So if we should all try get there on time and put all our efforts, because most of the time we end up underestimating the tasks. We think it will be easy, but you end up finding some issues along the way based on the experience you've had before. So if you can be able to finish things, reach there on time, you'd rather finish early and go home than go late and then end up having a lot of issues, you know.
Yeah.
So I would suggest people try and get there on time, then start doing the issues based on the tasks we've been allocated, and then try and combine everything and see if it will work, and make sure we check that the final thing can actually be assembled inside the rocket, you know. Yeah.
Yes. So I need to. Yeah, thank you very much.
The PCB fabrication, we have 4 PCBs that will be fabricated, Samir. I think those can be split.
Oh, by the way, I'm still wondering, so if these 2 PCB can be used with the 14.8-volt battery, we will just create 2. Yes, so, but conservatively, we have to create all of them.
And from past experience, we should complete 1 PCB fully, confirm that it's working before. Okay, because I believe this 1 weekend we spent, we fabricated like 5 PCBs consecutively. Then by the time we were etching them, like we were like, oh, it's not possible. Like, so we ended up wasting the whole day, and none of those PCBs are being used currently. So I suggest like the first hour or first 2 hours, just the whole PCB to be completed. Then if we upload the software and everything works fully, is now when you can indulge yourself in fabricating in mass numbers, like 3 consecutively. Because okay, there's in terms of splitting the work, I believe I can do maybe 2 people for ironing a PCB, since it will be done in shift, then 1 person for etching, and maybe 2 people for drilling. Or it's 1 person drilling 1 PCB. So yeah, I can say 1 power for making a PCB. Ironing is the most tedious, and etching is the lightest. So
okay. Okay. So we have to restore the items. It seems, okay, I just wanted to ask maybe Kisaka, because we have to ask Mohammed to purchase the components. And we were wondering which components we have to buy. So at least we have to recreate 2 PCB. And in the worst case, we have to create all of them. So in that case, the June identified some SMD component like flash memory. We have to repurchase it because it's a surface mount, so you cannot desolder it. Where is it? Yeah. So are there any components we have to repurchase it? If you can type it in the chat box, or anybody who can identify it so that the Mohammed can buy. And no information. So the paste for attaching the flash memory. Okay. Where can we buy in Nerokas? Nerokas, it is available. Okay. Do we need to buy flash memory 6 or 4? It seems 4, right? So the paste or flash. Plus. Is it enough? So you are satisfied? So everything can be desoldered and transferred to the new board. So that is 6 flash memories since some of the heat up and paired. Okay, so 6. Yeah, so, okay. Okay. Yeah, so I think that's okay. So Mohammed, I hope you took note. So this sheet is available. I just share just in case. And so you buy the connectors, 12, GPS. Oh, yes.
What I've noted down is GST 2-pin GST connectors.
Mm-hmm.
Is it 12 or 6 pieces?
12.
12 pieces.
Yes.
Okay, then flash memory, the one solder paste. What about the antennas, the GPS?
We need them. Now 6. 4 pieces.
Okay.
And this active antenna, UFL antenna for GPS.
So I buy the module and the antenna.
Yes. So the Ian was pointing out, like the default antenna might be short, so we have to buy another antenna which is long.
Okay.
Yeah, when you're purchasing the GPS, you can check the antenna length. If they're short, you can ask the guy to show you the other antennas they sell separately. Based on their website, they say they're supposed to be like 14 centimeters long.
Okay. Also, I appreciate if similar to Ian, if somebody knows, okay, I've checked the shop, and you can just share in the group the link so that I can know what exactly I'm looking for.
Oh yeah, there is. Okay, can you access this Google spreadsheet, which you are seeing now? I have shared a link on the chat box. Are you able to open it? Mohammed?
Yes, I can access it.
Yes, yes. So inside, there is a section for Mohammed. Yeah, here. Like these are the links. So this. Oh, okay. I think someone or Ian has put the link for it.
Okay, thank you.
Yes, thank you. All right. Anything else? Okay. So I think we can close now. So thank you for joining the 2 hours meeting. And especially Ian, thank you for your contribution, though you are busy. And I really appreciate.
You're welcome.
Okay, so tomorrow will be a long day, a busy day. So we are going to complete our mission. Yeah. So let's work together tomorrow. If anybody has any other comments, we can close the meeting here and have a nice evening.
Okay, see you tomorrow.
See you tomorrow. Bye. Good night.
Bye.
Good night.